Hello everyone, I am Satyam Kumar, a physics teacher. So, welcome to my YouTube channel, Satyam Knowledge Bank. Today I am going to teach you some new topics. Okay, so Faraday law of electromagnetic induction, I am going to start. Okay, so see. Faraday law of electromagnetic induction okay, so according to Faraday law of electromagnetic induction, whenever there is changes in the magnetic flux linked with the conductor, an induced EMF is produced in the conductor and accordingly induced current is produced in it. Okay, so whenever there is changes in the magnetic flux, that will cause the production of induced EMF and hence induced current will produce. Okay, so see now what is first Faraday law of electromagnetic induction, that whenever there is changes in the magnetic flux, whenever there is changes in the magnetic flux linked with conductor, induced EMF is produced in it and hence induced current. Okay, see here, whenever there is changes in the magnetic flux, linked with the conductor, that will cause induced EMF and hence induced current is also produced in it. So first I will explain that how we can change what is magnetic flux. What is this keyword? I will explain this keyword. What is magnetic flux, and now how we can change magnetic flux. By what factor, on what factor the magnetic flux depend, or by what means we can change the magnetic flux. Okay, so see, magnetic flux is the, see, this is our any plane surface. This is any plane surface. So suppose here three magnetic field lines. These 1, 2, 3 magnetic field lines crossing through this plane surface. So flux will be what? Magnetic flux will be 3. If there are 5 number of magnetic field lines passing through it, then magnetic flux passing through that surface will be 5. Okay, so what is magnetic flux? Magnetic flux is the number of magnetic field lines passing along area vector or passing perpendicular to the surface of conductor. Okay, so see, suppose this is area vector, okay, and this is magnetic field lines. This is area vector. Direction of area vector is always perpendicular to the this surface, means okay. And suppose the angle between area vector and magnetic field lines is theta, okay. Then we know magnetic flux is directly proportional to magnetic field lines. Magnetic flux is directly proportional to area vector. So we can write, and magnetic flux is directly proportional to cos theta, okay. So on these three factors magnetic field lines depend, okay. Magnetic field lines, area vector and cos theta, okay, where theta is the angle between area vector and magnetic field lines. By changing any of these three, we can change the magnetic flux, either by changing magnetic field or by changing area or by changing angle between the area vector and magnetic field lines. So we can write magnetic flux is what? So we can write magnetic flux is BA cos theta, okay. In vector force we will write magnetic flux is a scalar product of magnetic field lines and area vector. In vector form we will write magnetic flux is equal to a scalar product of magnetic field and area vector, okay. So you know magnetic formula of magnetic flux is BA cos theta. So by changing any of these three we can change the magnetic flux, okay. Now how we can change the magnetic field? Suppose with respect to time magnetic field increase or decrease, strength of magnetic field increase or decrease, then flux will also change, okay. Now how we can change the area of this plane surface? Either by contracting this surface or by expanding this surface, we can change the area of magnetic flux. Now how we can change the angle between the area vector and magnetic field lines? See, suppose suppose this is our coil, okay, circular coil, and suppose we rotate this coil with some angular velocity omega. Then due to rotation of this coil, angle between area vector and magnetic field line will change. How we can change? By rotating a coil with some velocity. If we rotate the coil, angle between area vector and magnetic field line will change. So value of theta will change, and value of cos theta will change. So in this way flux can be changed, okay. Faraday law of electromagnetic induction, okay. What is the statement of Faraday law of electromagnetic induction? That I am going to explain, okay. So we'll move ahead. According to Faraday law of electromagnetic induction, whenever there is changes in magnetic flux, induced EMF is produced and hence induced current is produced in it. Induced current flow in the conductor. Okay, this is the first law of Faraday law of electromagnetic induction. Okay, now second law, magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. Means magnitude of induced EMF will be directly proportional to the rate of change of magnetic flux. Mathematically, how we can write? See, induced EMF, magnitude of induced EMF is directly proportional to the rate of change of magnetic flux. Okay, now we can write induced EMF is equal to minus rate of change of magnetic flux. Okay, so minus, why is here minus? Because induced EMF opposes the changes in the magnetic flux. Whatever the induced EMF produce, that will opposes the rate of change of magnetic flux, that will opposes the changes in the magnetic flux. That's why it is minus, negative sign. Okay, so this is the law of Faraday law of electromagnetic induction.